Hello. Today we'll be presenting our final presentation for NAS security and penetration testing. My name is Ethan and my partner is Adam. So a little bit of an overview of our project. We had initially started with focus on enhancing the secure shell connection to our NAS device. But after some research and testing, we had found that this was a little bit out of scope for the time frame that we had for our project. After this, we had shifted the focus onto mainly NAS security and the implementation of that security. And with that, we will be doing some penetration testing to see the vulnerabilities in the software and the device and the operating system itself. With all this, we had a few challenges that we had faced, mainly just with the initial setup and the configuration of our Raspberry Pi and the configuration of the network, as well as implementing a few certain security measures. Some background for our project is just a NAS device itself. A NAS device is a network attached storage that can be used for business purposes or local purposes such as your own home. And it gives users the ability to store their data somewhere that isn't their computer. A few of the things that are important of NAS security are that it ensures data confidentiality and integrity. The critical for business operations and productivity, and to protect against evolving cyber threats. The problem statement that we have for our project is to find the vulnerabilities in the default configurations and weak access controls in a NAS device, as well as penetration test the vulnerabilities in place on the NAS. So initially we had started this project with the intention of enhancing the SSH connection, as we said before. And with this, we were thinking of using a key-based authentication as well as attempting to implement some form of encryption for the traffic. But like I had said before, after a little bit of research and testing, we had seen that this was a little too grand of an idea and a little harder to implement in the time frame that we have. So a couple of the main points that we had achieved was to set the security configurations on the device, and then evaluate the resistance to the penetration testing, as well as attack the NAS device using Hydra, and try and educate the users on best security practices, doing that with our documentation in the report. So a couple of the major components and working mechanisms are the penetration tools, the security monitoring tools, and the NAS device itself, like Raspberry Pi. And a couple of those tools that we had mentioned before are just like here. So for our Raspberry Pi, we're running the Open Media Vault. We use PuTTY as our SSH connection, and we use Discord and G Suite to communicate and have all our documentation. And then for a little bit of the penetration tools and security measure tools, we used John the Ripper and Nmap, as well as Hydra, Burp Suite, Ubuntu, and SecLists. So our metrics of evaluations for this project was to see vulnerability reduction rate, the time to detect and respond to incidents, the successful penetration test results, and user education and training completion rate, as well as the false positive rate. And next we have our demo that I will pass this over to Adam.
Okay, for the practical side and demonstration of what we kind of did, because we deemed it a little bit too difficult to enhance the security, I went in and tried to break it. So first, because I have the NAS set up on a Raspberry Pi on my network, the first thing I did was try to do all of this without previous knowledge of the device and what it's set up as, like the username and passwords. I had some liberties taken, but I tried to do it as if I had no knowledge on it at all. So the first thing I started with was an Nmap scan of the network to see if there was any devices on my network that would be out of the normal. And so the one that I found was my Raspberry Pi, and this is just a simple Nmap scan with OS information. So I picked up my Windows machine, Mac machine, a couple others, and then I found Raspberry Pi, which ended up being the outlier. And when I take that IP of the device and put it in the browser, just see what I get, because if it was something like a printer, you could still open up that IP and you could get the web page for it and all that. So I brought it over to the browser, and when I go to that IP, it brings me to the Open Media Vault login page. So this kind of tells me it's an NAS, and then it also shows the username and password, so I know that there's a login to it. With this, I opened Burp Suite, which is used for penetration testing web applications, and inside Burp Suite, what I was able to do was use it as a proxy so that when I go to send payloads, I don't overload the network and the NAS itself, but I can see what all this web application is sending, and then I can test the payloads later on without having to send those directly to it. And another thing with this is when we put in the test username and password, we get to see what exactly those variables are called when it's sent. And in doing that, we can specify where we want to add our payload. So we highlight the password here, as that's the one we want to test and try and break. We can also highlight the username and try and break that. What I'm using here is called SecLists. It gives us a huge list of usernames and passwords. They're compiled from database breaches and leaks of famous sites and whatnot. So it has a lot of information, as you can see by the payload count here on the right, about 14 million different passwords. The one I'm using on the left is just a simple, here's some very common usernames. But this lets us test each and every one of them. What I did here was I set the username to admin, as I just figured that's probably one of the most common ones. And then I tried running the payloads for the password. And each one of these is its own individual one. And as you can see, it just returns a 400 for each one. Each one failed. We didn't get any successes here. And then if I go into Hydra is more of a command line tool. And Hydra allows us to do some more in-depth things, like going after the device itself. So the first one here that I tried to use is the HTTP form attack, which is similar to what Burp Suite does, where it goes after that username and password login. And we're just specifying that we're using this RockU text file, and then for this host IP, using the admin login. And then what it does is it tries each password with the admin login to see where it gets. Hydra had some very interesting results, and I think it's because of the NAS security itself, where it's returning that everything was a valid combination due to the network setup of it. So I think once it realized, oh, you're trying combinations of passwords and we're getting multiple notices, that we're just going to return a rejected, or not rejected, but a notice that each one is correct. It doesn't say it's successful or it's failed. It just passes it. And I think that's why we get the 10 valid passwords found, because it doesn't recognize it. And then something I noticed with the Open Media Vault, just when I was setting it up and when I was doing some of my testing, a little bit outside of this, trying to break it, is that it is very easy to lock an account. After 3 failed attempts, it's completely locked and you can't get back into it without resetting it. And you have to do that from the device itself, and I just SSH'd into it to reset it. And as I was attempting to do these passwords, something I found was that if I edited the text file of payloads for the password, I could put the password in the first 3 and it would return the correct result. But if it wasn't in the first 3, then it would just keep trying hundreds of passwords without any notice of the account being locked or finding anything correct, even if the correct password was within those tries. But because Hydra has a couple different tools, something I noticed was I could then try and attack the SSH of it. And I skipped a step here and took a little bit of liberty and just went straight for my account, which is on the Raspberry Pi, just because I know existed and it saved some time. But you could search for that user as well. And you can find that username instead of just knowing what it is. But I just searched for my name, and then I tried a huge list of passwords to run against it. And what I found was the SSH into the device itself worked every time, no matter where I placed the password. If it was within the first 3, if it was all the way at the end of the file, Hydra would find the correct password for my login every time. And I blurred out my password because that's a password I actually use. But it would find it. And because of this, I could just SSH right in. And being able to log in with SSH to the device that is running the NAS is kind of a powerful workaround. As you can see when we start looking around, right in my home directory, you can see some Open Media Vault install files in configuration. If I go into the etc password file, I can see at the bottom of it, oh, there's an Open Media Vault web GUI or a Notify, 2 Open Media Vault accounts. And because of that, we can just simply look up how to get into Open Media Vault. With a single Google search, you can find this OMV Open Media Vault first aid command, which allows you to just reset the admin password for that web interface. So here, I just run that command on the account that I SSH'd into. I change the password. I just set it to password. And then hit OK. And it correctly changed the password. If I go back to the web interface and I run that new password with the admin account, it allows me to log right in. So even with all of the security that Open Media Vault had in trying to crack that password and login, it was still susceptible through another mean of breaking the SSH into that device itself. And because I was able to get access to an account that let me change the admin password of Open Media Vault. And then for our conclusion, kind of some things I've said already, the front door can be as locked as possible and fortified, but it's kind of meaningless if you can just walk around it. So in the findings for this, it's not always how secure that one thing is, but how secure it's minimizing the vulnerabilities elsewhere. You want to make sure your passwords are as complex as they can be, because in all the testing I did, it wouldn't have worked if I didn't manually put my password into that text file, because I searched through multiple of them. Because my password was complex, it wasn't in any of the text files. It wasn't a standard password that people just think of. and I manually put it in there to test the tools and that it was working. Although, a lot of times, and the passwords that I were using were from leaks of other sites. So if it was a password that I was using duplicate accounts of, it would have still been gathered. Because if it was used on a site that had a leak, I could have used that one, my password's in that text file, and then I could have just ran that, and there's my password again. If it's the same password on this device, then it can be easily cracked. And so we wanted to fortify the SSH of it, which is still something we hope to do at some point, but we weren't really able to achieve that for this semester. But we hoped that in showing the security of the device and how we broke it through roundabout means, that we can still kind of explore that SSH security later on